And if I go over, remind me.
Sure.
It will strictly be because I'm not paying attention to time.
No, it's all good.
Blowing up these things has been the biggest
Oh, yeah.
challenge of Windows 10. I hate
Oh, yeah.
that you can't size the windows precisely.
I do too. I mean, they just,
I think
it's
worse
worse
operating
than,
system. Yeah.
I
I know that
agree,
it
yeah.
takes up less space on the computer, takes up
Uh-huh.
less RAM, and it takes up less hard drive to store the
Mm-hmm.
operating system. But it's
Huh.
not as good.
It really isn't. I totally agree.
No, it's not as good at all.
No.
Do you recognize any of these problems?
Uh, 35. Yeah, I kind of, yeah.
I think so. I don't think I've gone deep enough. Let me go.
I don't think we've, actually, no, I mean, I thought you meant, like, have I ever done these before, but,
Well, I don't
yeah, we've never
remember
done
doing
these.
13 with you, but it seems like I remember doing 12.
Oh, we
Just
actually, I don't think we did we?
for the heck of it, let's review 12. Only because
Sure.
12 is so important in the scheme of ACT problems.
Yeah, definitely.
It's an average problem.
Uh-huh.
By that I mean it's a problem about averages, which is to say mean.
Yeah.
There's mean, median, and mode.
Uh-huh.
Mean is the average.
Mm-hmm.
Now, whenever you're faced with an average problem,
Uh-huh.
the word you want to remember is totals.
Okay.
Every solution involves figuring out totals.
Mm-hmm.
Okay? Just remember
Okay.
that. And I've never seen an average problem on the ACT that did not involve figuring out totals as the solution.
Yeah.
So, let's do number 12.
Okay.
Let you read it.
Cool.
So what's the first step?
What should be stored in most one game? So we want the average, so we want to,
No, we want totals.
just totals, so we want to add them all up.
There you go.
Okay. Cool, and then we divide by...
The total for the first 3 games
Uh-huh.
is what?
So let me see here. I got my calculator.
Yeah.
So 150 plus 195 plus 160. So I got 360. Wait, here, let me try that. I'm sorry. Plus 160. Yeah, 505.
Now, what's the totals for the 4 games that she needs in order to average 175? Notice that we don't really take the average into consideration whenever we do these problems.
No.
It's all about totals. Remember totals.
Okay.
What's the total number of pins she needs to average 175 for 4 games?
For 4 games. So would you just say 175 divided by 4?
Not divided by 4.
Multiplied?
Yeah.
Okay. So 175. 700.
Now, do you see where if she got 700 for 4 games, she would have an average of 175? Because you would take 700 and you would divide it by 4, and that's equal to 175. So the way we got 700 was to multiply 4 times 175, and that gave us 700.
Cool. That makes sense.
But totals is what you always want to think about.
Mm-hmm.
Well,
Yeah.
if she has a total of 505, but she needs a total of 700, what does she need to score on the last game?
175.
Use your calculator.
So you're just, so 700 minus 505, right?
Right.
Let's see. 195.
195.
Yeah.
Notice that if she scores a 195, she will have scored 150, 195, 160, and 195. And if you total those up, you get 700.
Uh-huh.
And if you divide by 4, you get an average of 175.
Cool.
So whenever you come across an average problem,
Uh-huh.
know that the solution does not come from comparing the averages.
No.
In other words, I could figure out what the average was from the first 3 games, but I don't want to. It doesn't lead me anywhere.
No.
The only thing that's worthwhile knowing is what the total is from the first 3 games.
Uh-huh.
And what the total needs to be for all 4 games.
Yeah.
Therein lies the solution to come up with what she has to score in the 4th game, which is 105.
Okay. Yeah.
All right.
Cool.
So, which of the following best describes a triangle in the xy coordinate plane whose vertices have these 3 coordinates? So,
Okay.
I'm going to start by drawing those 3 coordinates. There's 0, 0.
Yeah.
Another one is 3, 5. Well, nothing says I can't approximate. In other words, I do not have to put a grid on this thing.
Yeah.
No need to. It wastes time.
Uh-huh.
And the 3rd coordinate is 0, 2. Connect those 3 points and you have a triangle. Now read those 5 statements and figure out what best describes that triangle.
Okay. So we know A is not true because there's an angle that's more than
Correct?
90. We don't know if all the side lengths are the same.
Yeah, we do.
Do we?
This side length is clearly longer than this side length.
True.
Right? Okay,
Yeah.
so we know that's not true.
We know E is true. One angle measures more than 90.
There you go. You immediately found it.
Yeah.
And that's all there is to it. That's an obtuse angle right there. Measures more than 90.
Cool.
Number 14.
Okay.
What is the sum of the solutions? So the first thing we have to do is figure out the solutions of this quadratic. What's the first thing we can do with that quadratic? What's the first thing you always look to do when you're looking to factor?
Well, for this one, we could add 6 to both sides.
No? That's not what, when you have a quadratic, you're trying to make 0 be on one side. We already have 0 on one side.
Okay.
What we need to do is separate that into the product of a bunch of things.
Okay.
Okay? In order to do that, let's start factoring. Well, when we're factoring, the very first step is to see if there's a greatest common factor. Is there? Is there any number or variable that you can divide every term by?
24.
No. I can't divide that by 24. It gives me 1/12. When I say divide by, I mean and come up with a whole number.
Yeah, 2.
There you go.
Yeah.
2. That's the greatest common factor. And what it leaves behind is what?
2y, how would you do that? Just the another parentheses squared. Okay, yeah, yeah. Minus 2y minus 3.
Now, when you're doing math,
Mm-hmm.
at every step of the way, you want to be making sure you haven't changed anything.
Yeah.
Because all I'm doing is factoring. So this should be exactly the same as that. Is it?
Yeah. It is, yeah.
It is. If I distribute this 2, I get 2y squared minus 4y minus 6.
Mm-hmm.
So that's key. A key
Yeah.
concept when you're doing math is always be checking.
Okay.
Always be checking your work. Now,
Uh-huh.
you can't drop that. Actually, I can drop that 2. I can divide both sides by 2.
Uh-huh.
So now I have y squared minus 2y minus 3. Well, 0 divided by 2 is still 0. So I've simplified it. Now I have to factor this quadratic.
Okay.
Let's go through the factoring process.
Okay.
What's the first step in the factoring process?
You're trying to get rid of the y squared, right?
Okay? You split up the y squared. How should it be split up?
Y plus y.
Hold on.
Is that?
Y there and y there.
Yeah.
Remember
And then,
that this is going to be a y plus or minus some number, and this is going to be a y plus or minus some number. And when you multiply these two things together, the first term you're going to get is y squared. So that's why we take this y squared and we split it up into y times y.
Okay.
Now, what's the signs? That's the second step in factoring, is determining both signs, not just one of them, but both signs.
Yeah.
What are they?
So the next step we could do minus 1y minus 1y because it's
I
equal
don't want
to...
you to go there.
Oh,
I
okay.
want you to follow my methodology.
Okay.
First step is to split up the quadratic term.
Okay.
The second step is to determine both signs. Well, there's only one way you can produce a minus constant.
Okay.
And that's if the signs are opposite. So
Okay.
you know, one of them is positive and one of them is negative.
Yeah.
Now, the third step, and man, I wish everybody would learn how to factor using this method instead of the confusing, complicated California method that they teach you in school.
Oh yeah, that's horrible.
It is horrible, and there's no excuse for it.
No.
When you have first level quadratics, and by that I mean this term has a 1 in front of it, there's no need to use a complicated method.
No.
There's only one more step. And the step is factors of 3 that subtract, because of that negative sign, to the number 2. Well, what is that? We're looking for factors of 3 that subtract to the number 2. Well, let's list the factors of 3. What are they?
3, 6, 9.
No. When I say factors of 3, I mean what two numbers multiply to 3?
Just 1.
1 and 3. That's it.
Yeah.
Do they subtract to 2?
Yeah, that does.
They do. So
They do,
now the fourth step is to put the larger of those factors with the sign of the middle term. So 3 is the larger of the factors. I'm going to put that with the negative sign.
Okay.
Okay?
And then plus 1, yeah.
Right. Now I'm not done yet.
No.
I haven't quite figured out how to scroll down on this. Hold on a moment.
Okay.
I think if, no. There we go. So all I had to do was widen it a little bit.
Oh, okay, cool.
How do I solve that?
So now you would just y times y and then y times negative
Oh,
3 and then 1 times y.
no. That's doing the exact opposite of what I just did. I just took a quadratic and factored it. So you
Okay.
definitely don't want to just remultiply it together. You'll get this previous step.
Yeah.
How do I get a solution when I get this far? I got one thing times another thing equals 0. How can that be true?
Well, they have to be equal to 0 in
One
order
of them
for,
has to be equal to 0.
yeah.
So the way I solve it is I set y plus 1 equals 0 and solve that, and
Uh-huh.
y minus 3 equals 0 and solve that. Well, when I go to solve that one, what do I get?
Say you just subtract 1, so y is equal to negative 1.
And when I go to solve this one, what do I get?
3.
What's the product of those solutions?
The product.
Hold on. I'm trying to.
Okay.
God, hate Windows 10.
I know.
Oh, I gotta use this button down here.
Yeah.
What is the, not the product, excuse me, what is the sum of those two? What is the sum of the solutions of the equation there? Well, we
Negative 2.
just solved it. We got both solutions. What's the sum of them?
2.
That's the answer.
Cool.
So, like a lot of problems on the ACT, you have to do a number of things before you can actually come up with the answer. It's rare that you're going to get a question that you can come up with the answer in one step. Just doesn't happen. You have to do a couple of things first on ACT questions.
Yeah.
Now,
Cool.
you have to figure out how to advance. Okay, this is the next. Let me close that page out.
Okay.
Open that page. And again, I got to snap left on that. There's that page. Go. Almost. Advance that.
Cool.
Hold on a moment. Not so cool yet until I can expand this thing.
Yeah.
Oh, I needed that to come up. That opens that up. There we go.
Nice.
Boy, and then every time you move that horizontal bar, it shrinks it back up again.
Yeah.
This operating system sucks. I can't believe Windows would put it out. All right. Which of the following is the decimal equivalent of 7/8?
I got a 0.875.
Okay. You have a calculator in front of you?
I do, yeah.
There's nothing wrong with that. When they allow you to use the calculator, use it. If it speeds you up, use it.
Exactly.
Now, question 16 is a really interesting question. Go ahead and read it.
Okay. 60. Okay.
Complicated, right?
Yeah.
It's actually extremely easy.
I'm
There
thinking you
are,
just do, yeah.
yeah, go ahead.
I was just thinking you do 20 times 3, you get 60. And then, man, this question,
Not so easy, right?
you know. Then, would you just subtract 9?
Well, let me explain this to you. There's three methods to answer these questions.
Uh-huh.
One is algebraic, which you were kind of trying to do.
Uh-huh.
The other is back solving. The other is pick numbers and then back solve.
Okay.
And most people who take these tests want to do it entirely algebraic.
Yeah.
In other words, your inclination is to just plow into the math.
Uh-huh.
Well, what's really important to realize is that this is not a test to prove how much math you know.
No.
This is a test to get the optimum score.
Uh-huh.
It doesn't matter if you have to bunt in a run.
Uh-huh.
The whole purpose is to get the best score.
Exactly.
So algebraic isn't always the best way to do it.
Mm.
And back solving is frequently the best way to do it.
Okay.
And the perfect problems to back solve are what I call marble problems or age problems or things like that. Okay, let me show you exactly what I mean by back solving. First of all, when you're going to back solve, you don't start with the lowest.
Okay.
You don't start with the highest. Start with the second lowest or the second highest. I'm going to start with the second highest.
Okay.
So I'm going to assume that Billy has 30 marbles.
Mm-hmm.
Now let's work through the whole problem and see if we can figure out whether that's right or wrong.
Okay.
And that's what back solving means, is that you pick one of the answers and try to prove it or disprove it.
Uh-huh.
How many marbles does June have if Billy has 3? And it's always very important to assume that the first number you picked is correct.
Uh-huh. June has 60.
She has 20 more than Billy.
Because 3 times as many marbles.
No, hold on. That's Maria.
Okay.
June.
Oh, that's Maria, yeah.
So how many would June have?
40. I mean, 60. Dad, 50, gosh.
Huh?
50.
How many would Maria have?
Then Maria would have 60.
She has 3 times as many as Billy.
As Billy. So 30 times 3, so it'd be 90.
Altogether, they're supposed to have 100 marbles. Is this the correct answer?
No.
Do we need a smaller or a bigger answer?
Smaller answer.
The next smallest one, we have a choice of 16, 20, or 25.
Uh-huh.
Always choose the second smallest.
Yeah, so 20.
So I'm going to choose 20.
Mm-hmm.
Now let's go through all the others. If Billy has 20, how many does June have?
40.
How many does Maria have?
60.
What's that total?
120, so that still doesn't work.
What's the answer?
16.
That's the perfect question to back solve.
Yeah.
And here's the reason, is that most people, when they think they have to back solve something, they think they're going to have to try all 5 methods. Well, you don't. We only had to try 2. And that's always the case.
Yeah.
In other words, we tried 30 and we tried 20. We tried the second highest and the second lowest. And that's always the ones you want to start with.
Okay.
Now, had we been lucky enough to try 20 the first time, we'd have had the answer immediately.
Yeah.
Because we'd have known that 20 wasn't correct and we needed a smaller number than 20. There's only one smaller number on there, and that's 16.
Yeah.
So back solving is extremely effective as a manner of getting the answer. You do not have to formulate it algebraically. If I was to try to formulate this problem algebraically, and I said, well, let x be the number that Billy has, x marbles, that's the number of marbles that Billy has.
Yeah.
Well, now I would have to say that x, Billy's marbles, plus x plus 20, that's June's marbles plus 3 times x, that has to equal 100.
Yeah.
Well, that's 5x plus 20. When you simplify it, equals 100. So now 5x equals 80, x equals 16. That's the algebraic solution.
Okay.
Which was easier?
Yeah. The back solving much
By a
easier.
lot.
Yeah.
I mean, the algebraic solution is tough. First of all,
Yeah,
you have
for
to
sure.
figure out how to formulate it, and then you have to solve it.
Uh-huh.
Whereas
Exactly.
the solving solution only required me to take an answer and see if it could be correct.
Uh-huh.
I completely eliminated that tough step right there.
Yeah. For sure.
That's key. That's huge.
Uh-huh.
So always remember that if a problem lends itself to back solving, that's the way you should do it.
Cool.
Now, this is the first problem we've actually come across that does lend itself to back solving.
Yeah.
In other words, if you look at the previous problem, you didn't back solve that. You put in your calculator and figured out what 7/8 was.
Yeah, you see 7 divided by 8.
That's the algebraic solution.
Uh-huh.
But 16, we didn't actually have to figure out the formula for the algebraic solution, and yet we were still able to solve it by back solving.
Exactly.
It's gigantic. Never forget back solving when you're taking the ACT. And just so you don't forget, the results of the ACT math
Uh-huh.
are going to be as important to your future as your grade point average is.
Yeah.
There's almost nothing that a college counselor will look at more than your other than your batting average, than your math score on the ACT.
Okay. Yeah.
So we want to do everything possible to get that as high as we can,
Definitely.
just like your batting average in baseball.
Exactly. Awesome.
So it's not always about the math. Sometimes it's about figuring out the best way to do the problem.
Yeah, for sure.
All right.
Awesome.
Dylan, have a good day, and I will talk to you the next time. I'm not sure when. I think we have an appointment tomorrow night, but not.
I think
yeah,
so.
I think we do. So,
Awesome.
talk to you then.
All right. That sounds good. Thanks, Mr. Cowan.
All right. Bye-bye.
All right.